Nearly 70% of Toyota warning lights come on because of dirty sensors. Dust and oil slowly build up on them. The engine starts getting bad information, fuel economy drops, and the car does not feel smooth anymore. But instead of cleaning, most people replace these sensors, spending hundreds to thousands of dollars, even though the parts were never broken. That is why in this video I am revealing all the sensors that require 5 minutes of cleaning, not replacement. I know mechanics are going to hate me for this. Stick around, because neglecting sensor number 7 drops your fuel economy and drains your wallet like crazy. Sensor number 1, the MAF sensor. The MAF sensor is one of the most important sensors in your Toyota, but it is also one that most people never think about. The MAF sensor helps your Toyota figure out how much air is going into the engine. The engine uses this information to add the right amount of fuel so everything runs smoothly. Most Toyotas in the United States use a hot wire MAF sensor. Inside is a very thin wire that stays warm. When air flows past it, the wire cools down. The car's computer keeps track of how hard it has to work to keep that wire warm. That tells it how much air the engine is getting. Problems start when dirt builds up. Tiny dust particles, oil mist from some air filters, and normal road grime slowly cover the wire. When that happens, the sensor starts sending bad information. That is when odd things show up. The car may feel slow when you hit the gas. Gas mileage drops. Idle can feel rough. Or the engine may even stall at stoplights. Cleaning it matters, but you have to do it right. The wire is very fragile and should never be touched. Brake cleaner or compressed air can damage it. Only a proper MAF cleaner should be used. Just spray it gently and let it air dry. United States repair data shows nearly 40% of rich or lean fuel codes are caused by dirty MAF sensors, not failed ones. That means thousands of Toyotas are getting new MAF sensors when all they needed was a 2-minute cleaning. Sensor number 2 is the throttle position sensor. This sensor may look simple, but it has a huge influence on how your Toyota drives. The throttle position sensor, called TPS, tells the car exactly how much power you are asking for at every moment. The TPS is mounted on the throttle body and moves every time you press the gas pedal. Inside it is a small track with a moving contact. As the throttle opens and closes, the sensor sends different voltage signals to the computer. Low voltage means light throttle, and higher voltage means more throttle. The computer uses this signal to decide how much fuel to add and how the engine should respond. This information is critical. It helps the car know the difference between gentle cruising and hard acceleration. Fuel economy, smooth shifting, and throttle response all depend on the sensor working correctly. Problems start when the sensor wears out or gets dirty inside. Over time, the contact can wear grooves into the track. These worn spots usually form where the throttle is used the most, such as steady highway driving or stop-and-go traffic. When the signal drops or jumps in those spots, the engine gets confused. Acceleration can feel jerky. Power may cut in and out. In severe cases, the engine may even shut off briefly. But here is what most people do not know. Many TPS issues are not actual failures. They are contamination from carbon buildup on the throttle body itself. When the throttle blade gets caked with carbon, the sensor cannot read position accurately. A simple throttle body. Cleaning with the right spray cleaner often restores proper operation. Technicians often test the sensor by slowly pressing the gas while watching live data. Sudden jumps or drops in voltage clearly show when the TPS is truly failing versus when it just needs cleaning. Sensor number 3 is the oxygen sensor. It plays a huge role in fuel economy and emissions. The oxygen sensor, also called the lambda sensor or O2 sensor, sits in the exhaust and watches how well the engine is burning fuel. It helps the car's computer make tiny fuel adjustments continuously. These adjustments happen many times every minute to keep the engine running clean and efficient. Most Toyotas in the United States use a heated oxygen sensor. Inside is a special ceramic element that gets very hot. The sensor compares oxygen in the exhaust to oxygen in the outside air and sends a signal to the computer based on that difference. When everything is working right, the engine stays balanced. If the engine runs too lean, the sensor tells the computer to add fuel. If it runs too rich, it tells the computer to reduce fuel. Problems start when the sensor gets contaminated. Poor quality fuel, oil burning, or worn engine parts can leave deposits on the sensor. These deposits do not kill the sensor right away. They slow it down. A slow sensor sends late signals. The engine struggles to stay balanced. Fuel use goes up, power drops, and emissions increase. That is why many cars fail emissions tests even though no parts seem completely broken. This is the part that costs people the most money. Oxygen sensors are expensive, often $100 to $300 each, and most Toyotas have multiple oxygen sensors. But in many cases, these sensors are not dead, they are just coated. Light contamination from fuel additives or oil vapor can be cleaned off using a specialized oxygen sensor cleaner. The sensor needs to be removed, sprayed carefully, and allowed to dry completely. For sensors with heavy carbon buildup, a gentle soak in an oxygen sensor safe cleaner can restore function without replacement. The key is catching it early. Once a sensor is truly poisoned by silicone, lead, or other contaminants, cleaning will not help. But routine preventive cleaning every 30,000 miles can extend sensor life dramatically. That is thousands of dollars saved over the life of your Toyota. Sensor number 4, the engine coolant temperature sensor. There is another temperature sensor that quietly controls some of the most important engine decisions. That sensor is the engine coolant temperature sensor, also called the ECT sensor. This sensor tells your Toyota how hot or cold the engine really is. The car's computer depends on this information more than most people realize. When the engine is cold, the computer adds extra fuel, raises idle speed, and adjusts timing to help the engine warm up smoothly. As the engine heats up, those changes slowly turn off. The ECT sensor controls all of this. It is a simple thermistor. It changes electrical resistance as temperature changes, and the computer reads that resistance and translates it into a temperature value. Over time, this sensor can get dirty on the inside. Old coolant can leave behind sludge, scale, or corrosion. When that happens, the sensor starts sending the wrong temperature readings. The computer may think the engine is still cold when it is already warm, or it may think the engine is hot when it is actually cold. Either way, the engine does not run the way it should. This can cause higher fuel use, rough idle, hard cold starts, and cooling fans turning on at the wrong time. Over the long run, running too rich or too lean can cause extra engine wear. Many Toyotas with confusing drivability problems return to normal after the sensor is cleaned or replaced. The cleaning process is straightforward. Remove the sensor from the engine. Inspect the tip for corrosion or buildup. Soak the tip in electrical contact cleaner or in a mild vinegar solution to dissolve scale. Rinse with distilled water and dry completely. Reinstall the sensor with a new O-ring if it is equipped. This simple cleaning step prevents misdiagnosis and unnecessary parts replacement. If you made it this far, consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Sensor number 5, the knock sensor. The knock sensor is one of the most misunderstood sensors in your Toyota. It sits on the engine block, listening for abnormal combustion sounds. When fuel ignites too early or detonates instead of burning smoothly, it creates a specific frequency of vibration. The knock sensor detects that vibration and tells the computer to pull timing back to protect the engine. This sensor is critical for preventing engine damage, but it is also incredibly sensitive to false signals. Over time, the mounting bolt can loosen slightly. Oil, dirt, or corrosion can build up between the sensor and the engine block. When that happens, the sensor cannot hear properly. It might miss real knock events or report false knock that is not actually happening. False knock detection causes serious problems. The computer pulls timing aggressively. Power drops. Fuel economy suffers. The engine feels sluggish and unresponsive. Drivers often think their engine is worn out when the real problem is a dirty sensor connection. The fix is simple, but it requires attention to detail. Remove the knock sensor. Clean the mounting surface on the engine block until it is perfectly clean and flat. Clean the sensor mounting surface the same way. Apply a tiny amount of dielectric grease to prevent future corrosion. Reinstall the sensor and torque it to exact specification. Too loose and it will not sense properly. Too tight and you can damage the piezoelectric element inside. This maintenance is almost never done, yet it is one of the most important tasks for maintaining power and efficiency. Clean knock sensor mounting surfaces allow the engine to run optimal timing without false retardation. Sensor number 6, the camshaft and crankshaft position sensors. These sensors work together to tell the computer exactly where the engine is in its rotation cycle. The crankshaft position sensor tracks the crankshaft, while the camshaft position sensor tracks the camshaft. Together, they allow the computer to fire injectors and spark plugs at precisely the right moment. Both sensors use magnetic pickup technology. They sit very close to a toothed wheel or reluctor ring that spins with the engine. As the teeth pass by, they create a changing magnetic field. The sensor detects these changes and sends a signal to the computer. The computer uses the timing between pulses to calculate engine speed and position. Problems happen when metal debris accumulates on the sensor tip. Engine oil carries tiny metal particles from normal wear. These particles are magnetic. Over time, they build up on the sensor tip like iron filings on a magnet. This buildup creates a gap between the sensor and the reluctor wheel. The signal becomes weak or erratic. When that happens, the engine may have hard starting, intermittent stalling, rough running, or complete no-start conditions. The computer throws codes for camshaft or crankshaft position sensor correlation errors. Most shops immediately recommend sensor replacement, but in many cases, the sensor itself is fine. Remove the sensor and you'll often see a fuzzy coating of metal debris on the tip. A simple wipe with a clean cloth removes it completely. Clean the sensor bore in the engine, inspect the O-ring and replace it if worn. Reinstall the sensor. The problem disappears instantly. This is especially common in higher mileage Toyotas or engines with slight bearing wear. The increased metal content in the oil accelerates buildup. Regular cleaning every 50,000 miles prevents false diagnosis and keeps these critical sensors reading accurately. Sensor number 7, the mass airflow sensor again, but this time we are talking about the intake air temperature sensor that is often built into it. Many Toyota mass airflow sensors include an integrated intake air temperature sensor called IAT. This small thermistor measures incoming air temperature so the computer can adjust fuel delivery for air density. Cold air is denser and contains more oxygen. Hot air is thinner and contains less oxygen. The computer needs to know air temperature to calculate the correct fuel amount. The IAT sensor does this by changing resistance as temperature changes, just like the coolant temperature sensor. The problem is location. The IAT sensor sits right in the path of dirty intake air. It gets coated with the same oil film and dust that affects the MAF wire. But unlike the MAF wire, the IAT sensor is often overlooked during cleaning. People spray the MAF wire and think they are done. Meanwhile, the contaminated IAT sensor continues sending false readings. A dirty IAT sensor typically reads warmer than the actual air temperature. That makes the computer think incoming air is less dense than it really is. The computer reduces fuel delivery accordingly. The engine runs lean, power drops. Fuel economy suffers because the engine cannot make power efficiently when running lean. The fix is simple. When cleaning your MAF sensor, also clean the IAT sensor element. It is usually a small probe or cylinder visible inside the MAF housing. Spray it gently with MAF cleaner. Let it air dry completely. This ensures both temperature and airflow readings are accurate. Many mechanics miss this because they focus only on the MAF wire. The result is persistent lean codes or poor performance even after MAF cleaning. Understanding that the IAT sensor needs equal attention prevents comebacks and ensures complete repair. Sensor number 8, the fuel pressure sensor. Modern Toyotas with direct injection or returnless fuel systems use this sensor to monitor fuel system pressure in real time. It tells the engine computer if fuel pressure is correct, too high, or too low. The computer uses that information to adjust fuel pump speed and injector timing. The fuel pressure sensor sits in direct contact with gasoline. Over time, fuel varnish and deposits can build up on the diaphragm. This buildup prevents the diaphragm from moving freely, so the sensor reports lower pressure than reality. When the computer sees lower fuel pressure readings, it compensates by increasing pump speed and extending injector pulse width. That wastes electrical energy and fuel. It can also cause hard starting, stumbling during acceleration, or an inconsistent idle. Cleaning a fuel pressure sensor requires care. The sensor must be removed from the fuel rail, and the electrical connector must be protected from fuel exposure. The sensor tip can be carefully cleaned with carburetor cleaner or a fuel system cleaner. Use compressed air to remove loosened deposits and make sure the sensor is completely dry before reinstalling. Some fuel pressure sensors cannot be disassembled for cleaning. In those cases, running a high-quality fuel system cleaner through the tank can help dissolve deposits while the sensor stays installed. That is less effective than direct cleaning, but it still helps. Regular use of fuel system cleaners prevents heavy buildup and extends fuel pressure sensor life. This sensor is expensive to replace, often $150 to $400 depending on the model. Preventive cleaning is far cheaper than replacement. Sensor number 9, vehicle speed sensor and ABS wheel speed sensors. These sensors work together to tell your Toyota how fast it is moving. The vehicle speed sensor, VSS, reads transmission output speed. The ABS wheel speed sensors read individual wheel speeds. Together, they provide the computer with complete vehicle motion data. Both types use similar magnetic pickup technology. A toothed wheel spins past a magnetic sensor. The changing magnetic field creates an electrical signal. The frequency of the signal indicates speed. Problems happen when metal debris, brake dust, or road grime accumulates on the sensor or the toothed wheel. This contamination weakens the signal or creates false readings. The computer gets confused about vehicle speed, and this causes multiple problems. The speedometer may read incorrectly or jump around. The transmission may shift harshly or at the wrong speeds. The ABS warning light may come on. Traction control may activate unexpectedly. Cruise control may not work at all. All of these symptoms can occur from dirty sensors, not failed sensors. Warning: cleaning wheel speed sensors requires removing the wheel. The sensor is usually held by one bolt. Remove it carefully. Clean the sensor tip and the tone ring it reads from. Brake cleaner works well for this. Make sure all metal debris and brake dust is removed. Reinstall and torque properly. Cleaning is simple. VSS cleaning is similar. Access varies by model. Some are on the transmission, others on the differential. Remove, clean, and reinstall. The improvement is often dramatic. Shifting smooths out. Warning lights disappear. Speedometer readings stabilize. Improvement is common. This maintenance is almost never done until a sensor completely fails. Proactive cleaning during brake service or transmission service prevents expensive misdiagnosis and keeps all speed-dependent systems working correctly. Proactive maintenance saves money. Sensor number 10, sensor connectors and wiring harnesses. All these sensors only work if the wiring that connects them is healthy. If that system fails, even good sensors act badly. That is why connectors and wiring harnesses matter more than most people realize. Every sensor in your Toyota depends on three basic things. It needs power, a good ground, and a clean signal path back to the computer. If any one of those is weak, the sensor's information becomes unreliable. Over time, wiring starts to age. Engine heat, vibration, moisture, and small impacts slowly take their toll. Connectors develop corrosion. Pins loosen, wires break inside the insulation while looking fine on the outside. Grounds lose contact and reconnect as the car moves. When this happens, the car throws sensor fault codes. Scan tools point to bad sensors, but the real issue is not the sensor at all. The sensor may be sending a perfect signal, but that signal is being corrupted or lost before it reaches the computer. In many cases, technicians notice the problem comes and goes just by moving the wiring. Cleaning connectors with electrical contact cleaner helps. Fixing ground points restores solid connections. Repairing damaged wiring eliminates intermittent signals. Securing loose harnesses prevents vibration damage. That is why experienced technicians always check wiring first. Many bad sensors are actually good sensors with bad connections. The connector cleaning process is simple but important. Disconnect the connector. Spray both sides with electrical contact cleaner. Use a small brush to remove corrosion from pins. Apply dielectric grease to prevent future corrosion. Reconnect firmly. This maintenance extends sensor life and prevents false codes. It is especially important in harsh climates where road salt accelerates corrosion. A few minutes of connector maintenance can save hundreds in misdiagnosed sensor replacement. The pattern is clear. Most sensor problems are not sensor failures. They are contamination, corrosion, or connection issues. A dirty sensor sends bad data. The computer responds with warning lights, poor performance, and reduced fuel economy. Drivers panic and replace expensive parts that did not need replacing. Understanding this changes everything. Preventive cleaning is as important as oil changes. A few minutes of preventive cleaning prevents hours of diagnostic frustration and thousands in unnecessary repairs. The sensors we covered today control everything from fuel delivery to transmission shifting. When they are clean and connected properly, your Toyota runs exactly as Toyota engineered it to run. When they are dirty or poorly connected, every system struggles to compensate. This is why high-mileage Toyotas feel so different depending on maintenance history. Two identical cars, same year, same mileage, can drive completely differently. One feels tight, responsive, and efficient. The other feels sluggish, thirsty, and worn. The difference often comes down to sensor cleanliness. If you want your Toyota to stay smooth, efficient, and dependable for years longer than you expected, start thinking about sensors differently. They are not parts that fail randomly. They are precision instruments that need occasional cleaning to stay accurate. Before you click away, tell me in the comments which sensor surprised you the most. If you want more hidden fixes, secret maintenance tricks, and mechanic-level knowledge that saves you real money, make sure you hit subscribe, because the next video exposes another silent problem inside your Toyota that most drivers never discover until it costs them thousands.